Hey everybody, we are going to talk today, finish up our unit on similarity. So we already talked a little bit about shapes that get dilated are similar shapes, which is good to know, right? However, those shapes are going to have something very much in common. And we already talked about, so let's say we had a triangle ABC, and we had triangle that's a little bit off. Yeah, sure. We'll call it DEF. And if we want to talk about why or how these are similar, right, we don't have any ordered pairs, so I can't really say that that's a dilation. But remember, if I can say that the angles, the corresponding angles, are congruent to each other, then I know that that means that these two triangles have to be similar shapes if their angles are the same. And so what's interesting here is being able to talk about what exactly is the criteria that we would need. So for example, let's say I had can't draw very good straight lines today. This triangle. And this triangle. So we'll call this A, B, C, and probably D, E, F. And let's say that I told you that angle B is 42 degrees, angle C is 59 degrees, angle E is 42 degrees, and angle D is 79 degrees. And I said, hey, I would like to know if these two triangles are similar triangles. Well, in fact, what we would need to see if these two are similar triangles, we could see if one's a dilation of the other. Again, that's not really going to work here because we're not on a graph or anything. But there's this thing that's called angle-angle similarity. Angle-angle. And this marker is squeaky. I don't want that. Angle-angle similarity. And basically what that says is that if two angles are congruent in two triangles, they must be similar. They could be congruent triangles, but they must be at least similar. So if I can find two angles that are actually the same, then it would be enough to find that those two triangles have to be similar triangles. And so I noticed that I have angle B and angle E as congruent angles. But C and D certainly are not the same. One's 59 and one is 79. So I would need to find another angle. So we could use some different information. It depends on kind of what's going on. But here I would kind of use the idea that we know there's 180 degrees in a triangle. So I could probably find angle F here, right? So if this one is 42 degrees, this one's 79 degrees, that's going to be 121. And I could do 180 minus 121 because all triangles have to have 180 degrees. And that's going to give me 59 degrees. And so now when I look at 59, and this is 59, this is 42, this is 42. That's enough for me to say, hey, guess what? These two triangles are in fact similar. Because if two of them are the same, then the third one has to be the same because they all have to add up to 180, which is kind of cool, right? So I know for a fact that angle A here would have to be 79 because just like DEF, its angles are going to have to add up to 180. And if we know two of them, the third one would have to be the only thing that would get you to 180. So angle-angle similarity is going to tell you, hey, those two are similar or those two are not similar. If I can get two of the angles to be the same, then we're all good. So let's take a look at another one. Let's say I know, that was interesting. Let's say that I know this triangle here I got two triangles. We'll call this one A, B, C. We'll call this one C, D, E, something like that, right? And let's say that I know angle, let's call this one, right here is 114 degrees. I know angle A over here is 33 degrees. And I know, yeah, what else do I know? Let's say angle E is 81 degrees. Let's call it, yeah, that's fine, 81 degrees. And I want to know, are these two triangles similar triangles? So again, all we really need here is two angles to be the same. And I could tell you, yep, they're definitely similar triangles. So let's look at what we got here. Well, first of all, I can use some information that we know about this angle out here. I know it's an exterior, so we could use what we learned yesterday and figure out, hey, what is this angle? Because I know if I add A and B together, I'm going to get this angle on the outside. Let's do that. So 114 minus 33 is going to be 81. Hey, those are both 81. That's good. But I'm not so sure. Oh, we could do that over here too, right? So this is an exterior angle over here. So it's going to add up to the remote interiors. So 81 plus something has to be 114. So if I do 114 minus 81, haha, you guessed it, this one has to be 33 degrees. And then I could say, hey, those two triangles are in fact similar triangles because I have two angles that are the same. So there's lots of really cool stuff that we can do here where we kind of solve for two angles, and as long as we can find two angles, sometimes it's not going to work out. You know, they might try to trick you or something, give you something like that was squeaky. So this one, 40 degrees, and then maybe they'll do one like this. Where this one over here is 45 degrees. Well, if I want to see if two of the angles are the same, I know I got one, right? I got this one and I got this one. Over here, 40 plus 90 is going to be 130. That means this angle would have to be 50 degrees in order to be 180. Over here, 90 and 45 is going to be 135 plus another 45 is going to give you 180 degrees. And as you can see, only one of our angles this time turned out to be the same. So we could say these two triangles, they're not similar triangles. So sometimes they're not going to turn out to be the same. Sometimes they will. But that is one way we can prove if things are similar. This idea of angle-angle similarity. Yeah, cool. All right, tomorrow you get your review packet. Practice your homework tonight, and we'll work on some stuff. Get ready for this test. Cool.